So now we're going to take a look at chapter 2, which we're calling measures of central tendency, which is a fancy way of saying the middle. How do we find the middle of a group? And so to find the middle of the group, we first have to collect data. So we have to get our data from somewhere. We have to collect them from maybe a group of scores, an existing database. Maybe I want to look at my neighborhood and I want to get a sample of prices so I can find what is the middle of the road price for my house. But we're going to have to collect the data on those variables. Once I have that data, I'm going to want to get the distribution of what is the range of it. So again, if I'm sticking with my neighborhood, what are the prices ranging from? Maybe they range from $150,000 to $350,000. That range is really important because if I want to know the middle, I need to know where the middle is. What is it between? And then we're usually really interested in the middle because we can make a lot of assumptions if we know where that middle is. So we call that the mean, the median, and the mode. And a lot of times, if you've seen the mode in the past, it hasn't been taught to you as a measure of the middle, but there are times when a mode is actually the middle. So all three of those are going to be looking to generalize what is the middle. So the mean is what we are most commonly used to. It's how you calculate your grade. It's an average of scores. I add the numbers up, I divide by how many there are. That's how I would calculate my grade in the class. It gives you one single number that is what we can summarize and say, okay, here's the middle. So it's really nice. It's concise in that way. People are familiar with it. And it's probably most commonly used in all social science research. This is the most common thing because people have the most experience with it. All of us went to school. It is pretty useful. However, it doesn't tell us anything about how wide the scores are. So if I tell you that the mean of my neighborhood sales is 200,000, you wouldn't know that some houses sold for 350,000. And if you were pricing your house, you'd probably want to know if things sold for 150,000 more. So the mean is not accounting for how spread out things are or outliers in the data set. So this is why we sometimes have to question, should the mean be used, especially if it's not really in the middle of the range. So this is somewhere where we have to start asking questions and say, well, how far apart are the scores and what numbers are they between? And these are the places we start asking additional questions. The median, on the other hand, is still a score, and it shows us where the 50th percentile is in the data. So it's a little bit different. We're not adding things up. We're saying, okay, where is the exact middle? I'm going to list my data out from smallest to biggest, and I am going to find the number that's in the middle. That's what a median is. A median is really helpful when I want to divide a group into two groups. So in my neighborhood example, the median is going to be 250,000. So the mean and the median both measure the middle, but they did it differently because the median accounts for the spread in the data. The median is the number that occurs exactly in the middle, so it does take into account that distribution of scores and the range. So it's really useful in that sense, and it's useful whenever we have skewed data. So in this case, we have 350,000 kind of way out there, so it is a skewed data set because there's some really extreme numbers. And in that case, the median is the best measure to use for the middle. Now the mode is the score that occurs the most. So in our neighborhood example, if the selling price that happened the most was 225,000, then that would be valid to know as someone selling their home as well. That was the number that sold successfully multiple times. I would want to know that. It is the least used as the middle because it tells us the least amount of information. It doesn't tell me anything about the spread. It doesn't tell me anything about really the middle. It just tells me what occurred the most often, which can be something in the middle. Not always, though. So it doesn't tell us a whole lot, but there are times, like when selling your home, that you would want to know, well, what's the price that sold the most in the first 30 days? So let's take a little bit more of a zoom in. How do we calculate the mean? So first of all, we have different notation for the mean. We have the sample mean, which we call X bar. Then we have mu, which is the population mean. So those are two different notations for sample and population. It's really important to make sure that you're paying attention on the questions. S means the sum of. X is the actual data point, the actual data value. N is the number of scores in a sample, and capital N is the number of scores in the population. What is this fancy formula telling me? It's telling you to add up all the data points and divide by how many there are. That's exactly how you calculate the mean. And so that's what that notation really means. Add it up, divide by how many you are, and be sure to use X bar or mu appropriately. How do you find the median? You're going to put every data point in order from least to biggest. And then you're going to find the middle ones. The way I do it is actually cross out like one from the left and one from the right. And I keep going. And if I get two numbers in the middle, I add them and divide by 2. Or if I just get one score in the middle, that's my answer. So it's really easy if you line them all out and then cross off if you're doing it by hand. To find the mode, you're looking for the number that occurs the most. Technology-wise, if I was in Excel, I would be able to sort and quickly identify the mode. So the mode with larger data sets can be hard to do, but we can also use Excel or another function to sort. And if you have 150 data points, it is way easier to sort than it is to go through and count. One note is that we can have multiple modes. So the mode is the number that occurs the highest, but what if there are several numbers that occur with the same frequency? So what happens if 5 occurs 7 times in the data and 9 occurs 7 times in the data? It's bimodal. It has 2 modes. Once we get past bimodal, we just say it's multimodal. So it is perfectly okay to have more than one mode. So let's take a look at this example. We have the mean, the median, and the mode of a distribution. Here's my distribution of scores. To find the median, I'm going to add them all up. There are 8 scores, so I'll divide by 8, and I get 101.13. So mean is very much what we're used to. The median, what I do here is I would cross out 86, cross out 121, cross out 90, cross out 115, cross out 96, cross out 105, and I'm left with 96 and 100 in the middle. 2 numbers in the middle, so I add them up and I divide by 2, and that gives me the median of 98. If I am looking at calculating the mode, I'm just going through the 5-number data set, and I see that 96 occurs twice, so that's going to be my mode. Mode is probably the simplest one. Now, we talked a little bit about a skewed distribution. A skewed distribution happens when I have those outliers, and it means I have this kind of like hill that's going to occur almost all the way to the right or all the way to the left of the screen, and then the rest of it's going to be kind of flat. This happens when I have numbers that stick around an outlier or when I have a really large range. So when I'm working with a skewed distribution, the mean, median, and mode are all over the graph. So if this is a skewed distribution, then right here could be the mode, the highest point, but maybe my mean is here and my median is here. So they're going to be very different with how you look at them. And that's important to take note of as you start making graphs of these distributions. If I have a skewed distribution, then I can still use the same process to calculate the mean, median, and mode. They're just not all going to be in the same location like they would be in a normal distribution. If I want to describe what is the difference between a skewed and a normal distribution, it's really the position of the mean, median, and mode. So in a skewed distribution, everything goes back to the mean, median, and the mode not being equal. So what did we learn today? Summaries of central tendency, which is the middle, particularly the mean and the median, are used really often. The mean is not great when it is a lot of outliers. The median is better when we have outliers and a wide range. They each give us important information. More often than not, it's better to give more information than less. For some reason, people tend to give the mean and then they ignore the median and the mode. We have to learn to filter and say, well, would I want to know the median? Well, if you know the range and the mean is not actually in the middle of the range, then the answer is yes, you want to know the median and the mode. So for some reason, one or the other might be more useful or less useful than the other one. Without considering that, we'll make generalizations based on bad information. So if I'm looking to sell my house and someone tells me the mean is 200, but the mode was 225 and the median was 250, then it's pretty clear that I should be pricing my home higher than 200,000. So I'm making a decision based on a poor generalization because I didn't know to ask those other questions. So that's why it's really important that we learn to ask questions and to find data for ourselves and then be able to make a truly informed decision.